See if this one works. All right, so for this problem, yeah, pretty straightforward. Just do the force diagram of the truck, of the file cabinet in the truck, and then when I do that, I get the sum of the forces in the x is negative friction equals ma. So a is equal to negative mu g. That means I have the final velocity, which is 0, the initial velocity, which is 15 meters per second. Sorry, no naked numbers. And then a is negative 8 meters per second. I'm rounding off g to 10. So then x is equal to what? So then I would use x is equal to vf squared minus v0 squared all over 2a. And of course, vf is 0. So this is 15 squared is 225 divided by 16. So it's around, actually, it's around 15 or 14 or something like that. Yeah?
You know the chart in the book for the mu values?
Uh-huh.
Do you know which one to use?
Because if you look, it's like they tell you it's a steel filing cabinet, and I think they're assuming. Did they say steel truck?
Yeah.
Okay, so they said it's steel on steel, and then you just look. Is it kinetic or is it static? Well, we're hoping it's static. We're hoping it's not moving. So then it's static friction, and you just look for the one that matches. So it's just static friction, steel on steel is 0.8.
So it said it moved.
Yeah, if it moves, then use kinetic.
How do you know when it starts moving?
Yeah, once it starts moving. So if they tell you that it's sliding, yeah, but they, let's say it's sliding and this distance is 4 meters, what mu would it have to prevent it from hitting this? Then you would say that.
How do you know which way friction is?
What?
How do you know which way friction is?
Logic. The trick to figuring out which direction friction is just pretend like there's no friction. If this was you in the back of the truck and you're sitting on, I don't know, a skateboard and they slam on the brakes of the truck, what happens to you?
You crash. Stay still. You bounce on the ball.
You see it? If you're on wheels in the back and they slam on the brakes, you're going to keep moving because of Newton's first law of inertia. So an object moving stays in motion, blah, blah, blah. So then you'll go boom in the back of the truck. Any other questions?
Wait, so what did you use to figure out what x was?
Then I just use this equation. What does this come out to be? I use, what is this equation? It's like the third equation on your formula sheet. Whose is that? Oh, is that a calculator? Is that a calculator? How come it's so small? Okay, yeah. Please.
I don't understand the second part.
This part?
Yeah, from the top.
From this part? Okay, this makes sense, right?
Yeah, that's acceleration is mu times gravity, right?
Yeah, negative mu g. So then that's around negative 8 meters per second squared.
Oh, you're using negative because you're going that.
Yeah, exactly. Because if the acceleration was positive, then it would kill this person in the front. Other questions? Anyone else? Yeah.
How did you incorporate that to find out when it stopped?
Oh, so then what I said was, then it's like I went back to chapter 2. And I said, okay, I know initial velocity, I know initial velocity, I know final velocity, I know acceleration, I want x. What equation has those variables?
But don't you have to incorporate the friction on the steel?
That's it. Where'd mu come from? Mu, I looked it up. It was 0.8. So that's how you incorporate the friction on steel.
So you incorporate that into your acceleration?
Yes. Okay, any other questions? Good.
So basically all you did was find out what, how do you get us the mu f of n is equal to negative mu m g?
Because f of f is mu f sub n. I just substituted. On your formula, on your formula sheet, doesn't it say this? F sub f is less than or equal to mu fn. I think they call it n, but whatever. And so that means if we're talking about max f, then we can say that it's equal, right? And then I just substituted right there.
So negative f of f is equal to na, and
So then I substituted. Right? So see, that's what I did. I substituted this into here to get that. And then when we look at this force diagram, do you see Fn equals Fg? So that means the sum of the forces in the y is equal to 0. So Fn is equal to Fg. That means Fn is equal to mg. That's why this Fn became mg.
Oh, so that's why you got F.
Yeah. Yes. Shh, please. Sorry? Because which way is friction pointing? Okay, any other questions?
Wait, so that, that's the formula. A equals negative mu times. A equals mu times g on the top.
Yes.
So that's one you should memorize.
No. I mean, if you want to kind of remember it, it's okay. That's fine. You know, that an object on a horizontal surface sliding to a stop, that's always true. As long as there's no other forces except friction. But it would be better for you to do this. Because if somebody throws in something else, then... Yeah. All right, so I think that's enough.